Hi everyone. In this video, we are going to look at percent application problems. From the last video, you already know that a percent problem has three components in it: percent itself, and a part, and a whole. Okay, so when we have this application problem, they can only ask three different kind of questions because we only have three components in a percent problem. That's why we only have three learning objectives: solving for the part, solving for the whole, solving for the percent. That's how it is. Now, the key is identify which one you're looking for. Now let's go straight to the first example. Say identify which part is which. Example 1, 30% of a 400 milliliter solution. The solution is liquid, right? Like acid solution, all of those solutions. 30% of a 400 milliliter solution is acetone. How many millimeters of the solution is acetone? So it's not that the whole thing is acetone, it's acetone solution. So how many milliliter pure acetone in it? 30% of this whole thing is acetone. We are looking for acetone. How many milliliters of is acetone? So 30%, we don't know. This is our X. 30% of, percent of means multiply this whole thing. The thing after percent of is whole thing, right? Remember that? Is this part is the one that we are looking for. So basically 0.3 times 400 equals X. X is 120 milliliters. And that's all for this problem. Next one here. Harry earns a total earns 15%. Carrie earns 15% of total sales as commission. If she sells $2,485 in merchandise over a 2-week period, what is her commission? Commission is just a portion of your total sales, in other words. So commission amount is part. The whole thing is the sale, total sales. So we're looking for her commission amount. This is our X. Her commission, 15% of the total sales, which is this, is her commission. So we just write down what we read, basically. As long as you know percent of means multiply, you have to multiply by the whole thing after percentage. So 0.15 times 2485 is going to be our answer. 2485 times 0.15. 372.75. 372.75 cents. That's her commission. Example 3. Tedra sells real estate and receives a commission of this amount. So in this problem, we are given the commission amount. If her commission rate is 6%, so we are given the percentage. What was the total sales? Again, even though we are asked to solve for different component in this problem, but basic structure is still the same. A percentage of total sales is the commission. So the commission, we're looking at total sales, that's our X. Commission, whatever this amount is a percent, some percent of the total sales. Total sales is X. So to find X, we divide by 6%. And 6% is 0.06. Divided by 6% on both sides. So let's do the calculation. 54, 45, and 60 cents. Remember, 6% is 0.06 equals. So total sales is 90,760. Yeah, that's her total sales. How do you know this is the right answer? If you multiply this number, total sales, by the commission rate, you get commission amount should be this number. That's how you double check. Now B, a reporter states that 456 people in the survey indicated that they believed their schools were safe. The reporter went on to say that this was 48% of the respondents. That means 48% all of the respondents in the survey said the school were safe. Their schools were safe. How many respondents were involved in the survey? So apparently, these people, 456, they said their school was safe. They are only part of all of those respondents, right? So this is the part. So the whole thing is all of those that participated in the survey. So among all of those participated respondents, 48% of them said, 48% of them actually is 456 said their schools were safe. In other words, we're looking for this X is the whole thing. 48% of this whole thing said the schools were safe. And those people, 456 of them, just 456 people said school were safe. And 48% of those surveys said the school were safe. That means this 48% of the whole thing is this. So now I just need to, again, whenever we set up any equation in mathematics, the logic has to make sense. Okay, this portion of the survey are these actual people who said school were safe. Now cancel x equals 456 divided by 0.48. And this is going to be a whole number because the number of people cannot be decimal. If you get a decimal, that means either this 48% is a rounded number or something else is wrong, actually. 456 divided by 0.48. I got exactly 950 people. Yeah. Now the last part of this video, since in the previous examples we calculated the part, we calculated the whole. Now we calculate the percent. Now let's look at the example here. Natasha answered 52 questions correctly on the test with a total of 60 questions. So total number of questions, out of this total 60 questions, she answered 52 of them correctly. What percent of the questions did she answer correctly? We're looking for percent. Apparently, X% of all of these questions she answered correctly, which is 52. So that means 52 is that percentage. We just want to solve that percentage to represent the number of questions she answered correctly, which is this. 52 is X% of 60. So X equals 52 divided by 60. Oh, a lot of 6, 0.866 forever. So we need to convert this one to percent, say 86.666% forever. So you put a bar on top of 6 to indicate it's a repeating digit. Next page. We just have one more on the next page. A manufacturing plant produces 485 units of its product in 1 week. If 3 units are found to be defective, what percent of the units produced are without defect? Now, this is a little bit more challenging. It's not much, but a little bit different. first of all, we are looking for percentage, but this say this a total number of units of product produced in that week, and three of those, this is actually three of them are found to be defective. But we want to have the percentage to represent those units that are not defective. Yeah. So in other words, percentage of those are not defective. There are two different ways to do that. I'm going to do both ways. First, we do it straight. Since this percentage represents those without defect, we have to have a number that is corresponding to this percentage. So that number is 485 minus 3, 482. These are the units that without defect, right? This is a percentage of the whole thing. So X% of 485 units are not defective. The X% of this must be 482. They're not defective. These two have to have same meaning. One is the actual amount, one is the percentage. That means this number of units without defect is X% of the whole thing. That's what we are looking for. So we divide by 485. 485. This is going to be a high percentage. 482 divided by 485. 99.38. We take two decimal digits, 0.9938. Move two decimal places to the right. 99.38% are without defect. This is method 1. Now, method 2, we can still work with these 3. You just keep in mind 3 represent those that have a defect. So what percentage of total production in that week is defect? So X%. Now this time X% represent units percent of units with defect. Okay. So X% of this whole thing have defect, which is 3. 3 units have defect. So we divide by 485, divide by 485, canceled. So 3 divided by 485. We get 0.006186. Now convert that to percent, move 2 decimal digits to the right. We get 0.62%, rounded to 2 decimal digits. Now, this is not our final answer because this X% represents those units that have defect. We are looking for the percentage of those units that without defect. How do we do that? Either you have defect or not. The whole thing is 100%. So the answer must be using 100%, subtract this one, 0.62%. So 100 minus 0.62, what do we get? 99.38. Now we get the same answer for sure. Just different way to do that. Okay, that's all for this video. See you guys in the next one.